For 2, 5. We are doing literal equations. You're going to see a lot of formulas, like the circumference formula, the area formula, the perimeter formula, a lot of formulas that will show up in the rest of your math career, and a lot that you've already seen, actually, a lot that you probably already know. So literal equations are equations that are going to have more than one variable, so 2 or more variables in the problem. And what we're going to do is have to figure out an answer to those more than one variable problems. So we're going to do, for our first one here, it's going to say we have 10x plus 5y equals 80, where x equals pizzas and y equals sandwiches. Oops. Okay, so x is pizzas, y is sandwiches. The question is, how many... Dustin, you need to leave again. This is not working. Outside. How many sandwiches can you buy if you buy 3 pizzas? Yeah, we're going to solve it. Okay, so if you buy 3 pizzas, how many sandwiches can you buy? Okay, now here's the thing. If we're trying to figure out a different number of pizzas for a different number of sandwiches, like what if I said, what if we buy 6 pizzas, then how many sandwiches could you buy? It's a whole lot easier if you have your thing you're solving for, like sandwiches, isolated. So what we're going to do is we're going to solve this problem for y right now. Okay? So let's rewrite it here. 10x plus 5y equals 80. Okay? If I want to solve for y, what should I get rid of first? Not the 5y. Nope, the 10x is what we're going to get rid of first, right? Think of it right now as like, let me just give you another example. Say we had 70 plus 5y equals 80, right? The first thing we would do is we would get rid of that 70 so that we can get closer to isolating the y. Okay, that's not our actual number. I just want you to see where I'm coming from here. So if I take away the 10x and take away the 10x, then this is gone. On my left side, I have 5y. Bring down my equal sign. Now, here's where people have the issue. It's 80 minus 10x. Can we subtract that?
Yeah. Yes. Wait, what?
Oh, yeah. You have a variable with the one and you don't with the other, okay? So this is where it's different. We're going to do 80 minus 10x, and we have to leave it like that. Okay, but we're still trying to isolate the y. We still want to get y by itself. So how do I get y by itself right now? Divide. So you are going to divide by 5 here, which is going to cancel that. And then you have to divide by 5 here. Okay, so on the left side, we have y. On the right side, you're actually going to divide both parts by 5. So 80 divided by 5. And 10x divided by 5. Okay, so 80 divided by 5 comes out to 16. And then 10 divided by 5 is 2. 10 divided by 5, so you get 2 and then you have your x there. Okay? So now this is an equation that means the same thing as that original equation we started with. It's just that now the y is by itself because we're trying to figure out how many sandwiches we would be able to buy with a different number of pizzas. Okay? So think back to the question. How many sandwiches can you buy if you buy 3 pizzas? Well, pizzas was x. So if I plug in a 3 right here and solve that, it's going to tell me what my y would be. So I would do y equals 16 minus 2 times 3, or 16 minus 6. So how many sandwiches could you buy? 10 sandwiches. Okay, so that's if we did 3 pizzas. We could buy 10 sandwiches. But what if we did 6 pizzas? You're going to go back to that original equation that we came up with and plug in a 6 instead. So y equals 16 minus 2 times 6 would be 16 minus 12. So that means we could buy 4 sandwiches if there were 6 pizzas. We can buy 10 sandwiches if we bought 3 pizzas. Okay, so it's just giving you how many you can do. You don't have to rearrange it. You could just plug the number in and then solve. But this gives you, because we have so many like different options for what if we had 3 pizzas? What if we had 6 pizzas? What if I wanted 7 pizzas? Because we have different options there, it just makes it easier to solve for y first. Okay? Okay, this next one. They're going to say solve ax minus bx equals c for x. Okay, ax minus bx equals c. We're going to solve for x. Now here's the thing. Don't look back there. Don't look back there. So here's what we're going to do, okay? Ax minus bx equals c. If we want to isolate the x, let's pretend there's numbers, okay? These are not true numbers, but pretend there's numbers right now. If I said 2x minus 3x equals c, how would I simplify that right now? Right, we would combine the like terms. We would do 2 minus 3 is negative 1x, okay? But we don't have numbers. We have letters. So what do we do with these? You subtract them, okay? So what we're going to do is we're going to kind of do the distributive property in reverse. So we're going to take it as a minus b times our x, right? That's essentially what we did. If we're looking at numbers, it would be 2 minus 3. Well, our 2 and our 3 are a and b in the problem. So we're going to say a minus b times x equals c. Okay? Now let's ditch that. I want to get x by itself. What operation is happening between x and my parentheses here? Multiplication, okay? If I want to get rid of something and we're multiplying right now, what's doing the opposite? What's the opposite of multiplication? Division. So what we're going to do is we're going to divide by a minus b, which will cancel this out. And whatever you do to one side, you have to do to the other. Divide by a minus b. So we get x equals c divided by a minus b. Okay? And it said solve for x. We have isolated our x now, so we're done. Kind of weird, right? Because you don't have numbers, you're just moving letters around. But it's the same steps. Okay? Same steps as if you had numbers. Let's do this one. Okay, if c equals 2 pi r, and we're going to solve for r. Okay? Right now, c equals 2 times pi times r. How do I get r by itself? What do I have to do with the 2 and the pi?
You multiply and then you divide.
Right now, you're multiplying, so we have to divide, right? If I want to get rid of them, I have to divide by them. So divide by 2 pi, and they cancel out. But whatever you do to one side, you have to do the same thing to the other. So divide by 2 pi. So what you're left with is r equals c divided by 2 pi. And that would be your new equation when you solve for r. Okay, so it's isolating a variable. You just have to figure out which variable is it that we're trying to get alone. It is the 3.14, but we're not rounding it. So it's pi is a number that never stops, right? 3.141592, blah, 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 it keeps going. So you're not going to change it to that number. It is a number. Pi is a number as a symbol. It's just a number that we can't put an end to. So you're going to leave it as the pi symbol. It's not technically a variable. It's technically a number, but it's holding a place just like a variable. Yeah. Okay. Okay, how about this one? If I tell you D equals RT, and I say solve for R. Okay, D equals RT. Do you recognize that one? Distance equals rate times time, right? Distance equals rate times time. So if we want to solve for a rate, what would I have to do to isolate R? How do I get R by itself? Divide. You're going to divide by T here and divide by T here. So you get R equals D divided by T, and that would be your new equation. Okay? How are we doing with this? Okay, I want to do one more. Let's say perimeter equals 2 times the length plus 2 times the width, and I want to solve for L. Okay, so I want to get L by itself. What's the first thing I should do? Get rid of the 2W. Okay, so right now we're adding it. So how do I get rid of it? Subtract it. We're going to take away 2W and take away 2W. So this is gone. P minus 2W, you can't do anything with. So you write it as P minus 2W. Okay, so that's my left side right now. My right side is L. What do I do next? Divide by 2. And when you divide by 2, you divide everything by 2. Okay, so you can write it as one big division bar like this, and you'll be left with P over 2. You could write as 1/2 P, or you can write it as P over 2 minus, what's 2 over 2 going to get us? 1, right? 2 over 2 is 1. So really all we have left for that one is the W. So length equals the perimeter divided by 2 minus the width. Okay, that's perimeter formula. Width and length are what you're working with. So that's a lot of what you're going to be doing today, is just rearranging, solving for a different variable. Because if, for instance, I was saying, what's the length? If your perimeter is this and you need a length or a width of something else, I could plug in a number for P and a number for W and solve, and I would get L. Okay? So that's the whole point behind literal equations. I'm not going to go into depth on that aspect of it, but this is how you would set them up. Any questions? All right. For